Here's lesson 6.4. So we're going to be interpreting graph that passes through the origin. So the volume of water wasted from a leaky faucet and the time when the volume was measured or shown. So we have a chart here, we have a graph. So first thing we have to do is plot the volume of water wasted against time. So with time on our x-axis, we have volume on our y-axis. So we have to plot it. I already kind of set up the graph here. So when time is 0 seconds, water wasted 0. So 0, 0. And at 10 seconds, 15 is wasted. 20 seconds, 30 is wasted. 30 seconds, 45. Okay, so we can kind of see a pattern. And then draw a line of best fit. So let's connect these. So this is our line of best fit. Describe the graph, so it's a linear relation. Choose 2 points from the table of values and calculate the rate of change. Okay, so these could be our points. 10, 15, and 20. So let's find the rise. Our rise is 15. Our run will be our x value, so 20 minus 10 equals 10. So we have our rise is 15, our run is 10, so our rate of change, so rate of change, just write it. So rise over run, we can put that in lowest terms. That's our rate of change. Okay. Explain what the rate of change represents. So the rate of change represents for every 2 seconds, 3 milliliters of water is wasted. Determine the first differences. So first differences, well, you can see there's a triangle here for volume and there's a triangle for the time. So what that triangle means is the rate of change or the first differences. So I'm just going to write the answers. It's 15. If we did the math, 75 minus 60 is 15. 60 minus 45 is 15. So it's all 15 here. For time, it's 10. Okay. So compare your rate of change with the ratio volume, or the change in volume and the change in time. So our change of volume is 15, our change of time is 10. So same thing, it's the same. Okay, so if we just find the rate of change this way, we don't really have to go through this whole process of rise versus run. You don't have to pick 2 points and then do the math. It's easier if we just do this step, right? The rate of change of volume divided by the rate of change of time. Okay, write a rule to determine the volume of water wasted when you know the time since measuring began. So, since ours is volume divided by time, we know that. If we know the time, let's see. If you know the time, it's going to be, we'll just put 1.5 times time. So whatever the time is, if you multiply by 1.5, you're going to get it. You get the answer. Okay? So whatever your value is for time, if you did in your calculator, 20 times 1.5, you get 30. 30 times 1.5, you get 45. So that's our rule. Well, that's going to be the same as our equation too. Let's see. List the variables. So we have time and water wasted. The water, rate of change. Write an equation. Okay, so 1.5 times our value for time, that's our equation. So we'll use that now to use our equation to confirm the volume of water after 15 seconds. All we have to do is 1.5 times t, which is 1.5 equals times 15 seconds, which is going to equal 22.5 milliliters. Use your equation to determine volume of water after 22 seconds. So same thing, 1.5 times t, and in this case t is 22, so 1.5 times 22, and we get 33 milliliters. Okay, now on to the next page. We have a new chart here and a new graph, so what does it say? First, plot the points. So when cost is $4, our mass of the snack is 200, okay? 408, so line it up. Looks like it's going to be another linear relation. So draw a line of best fit. There it is. Choose 2 points on the graph and determine the rate of change. Then compare your rate of change to the ratio change in cost divided by the change in mass. So we can just do the same thing we did last time. So let's see. We'll pick 2 points. 200. 4, you could pick really any 2 points. But I just choose the first 2. Usually you can pick the first and the last. You can pick the last 2. It doesn't matter. That's fine. So our rise will be 8 minus 4 equals 4. Our run will be 400 minus 200, which equals 200. So our rate of change is going to be a rise over run. So rate of change rise over run 4 over 20, 200, sorry, 4 over 200. Lowest terms would be 1 over 50. Okay, so there's our rate of change. Now we can just, let's compare it to the ratio. So change in cost, so we need to figure this out. It's always going to be 4. Here, 200. So we have to figure out what's the change in cost, which is 4. This is our ratio. 4 over 200, it's the same. So again, like I said last time, we could just look at our rate of change without having to pick 2 points. Right? We can just look at the rate of change to determine we'll get the same, if you do the ratio, we'll get the same answer as our rate of change, and it's just easier. Okay, so write a rule. I mean, we can write this one in words. For every 50 gram of a snack, it costs $1. That's what this is saying, basically. 50 grams of a snack costs $1. Okay, now we have to write an equation. Okay, so what's define our variables using letters? So our mass, we'll put our variables m, and then cost will be c. Okay, so we have to write an equation. Okay, let's see. Well, we can just say, we could do 2 equations actually. So once is defined for our mass, so we can say our mass will equal, our cost will equal mass divided by 50. So I should just put m here since we already just put variables. So if it gives us our mass, all we have to do is divide it by 50 and we'll get our cost. Okay, so something is 2 kilograms. So far it's been grams. Kilograms, if we know the conversion, we know there's 1,000 grams in 1 kilogram. So we know this is going to be 2,000 grams. Okay, so let's see the cost. Cost will equal 2,000 divided by 50. If you have your calculator, you know that that's $40. So we'll just put $40 here. That's our answer. Okay, so that's it for 6.4. Let me know if you have any questions.